So introduction to signal and noise in communication systems. So what we will learn is analog and digital signals. Introduction to dB in communication. dB is decibel. And then we will also talk about bandwidth and information capacity. We will also do some noise. Oops, sorry. Oh, what did I press? Okay. We will also do some noise calculation and analysis. Okay, the reason why I'm not doing slideshow is because I want to be able to draw like this. Okay, so forgive me if this is not in slideshow. I've tried to maximize it as possible. Okay, so communication systems is divided into terminal movement, whether it's fixed or mobile. Okay, and then for example, mobile is your handphone. Your handphone is mobile. And then we have fixed, like the towers or LoRa. I'm hearing some background noise. Someone. Oh, okay, someone muted already. All right. Okay, and then we have operating frequency, long wave, medium wave, short wave, microwave. Then we have location. Is the communication on ground? Is it in the air for aeroplanes? On ground, we are using it. And then is it in deep space for, satellites, for rockets? So how do they communicate? So that is part of communication system as well. And then you have underwater communication as well. How do marines communicate? How do submarines communicate with another submarine? So those fall under communication system. And then we have users. Is it going to be public? Is the communication going to be public? Is the communication going to be private? So those are the things that you need to consider. And then we have transmission channel. We have wired and wireless. I think you know this. And then signal, we have analog and digital. This is what we're going to cover a lot in this class. And then we have modulation, amplitude, frequency, frequency shift, phase shift. And this is what we're going to tackle in this class as well. And then we have signal transmission mode. This is just like side character, not the main one. This is the main. Okay. So yes, we're going to learn about this a bit, but it's not going to be like the core of this course. So the core is going to be on these two. Okay. The rest maybe in your fourth year, I believe there's an elective called mobile communication. Tak ingat lah. But I think you will tackle this, the location and stuff like that. Okay. All right. So this is the general model of electronic communication system. So you start with your information. It can be audio, like what I'm talking. So that's audio. I am here. So this is video. And then data. Data can be in the form of numbers. Data is also video. Data is also audio. It depends on how you term it. So let's just stick with information for now. So this is information. We want to transmit information, and our transmitter, abbreviated as TX, our transmitter will convert the raw signal into electronic signal, and then it will be transmitting it over the communication channel or medium. Okay, communication channel. Okay, kalau right now I am transmitting this information, my audio and my video, over Wi-Fi. So that it. So the communication channel is air, right? Communication channel is air. So free space, air, wire, cable, and then a fiber, optic cable, etc. So there are a lot of communication channel or medium, and sometimes there are going to be noise introduced to the communication channel. For example, you have your TV, Astro, right? Astro uses this plate. I don't know if Astro still uses that plate, but I think you know what I'm talking about. Astro has this plate dish, they put it on the rooftop. And when it rains, suddenly your TV is no longer working. Because why? Noise has been introduced by the weather. And when noise is introduced too much, the signal is disrupted and it cannot be transmitted to your TV. So that is noise. Noise can be due to weather. Noise can be due to we'll talk about more about noise. But there's a lot of different types of noise. Okay, so afterwards it is transmitted to the receiver. Like I mentioned to you before, your TV is a receiver. It receives the signal channel that you want to watch and pops it out so that you can see it. So it's a receiver. Okay, and when you can observe what the channel is showing, like drama TV tiga or whatnot, that is the information that you wanted to get. So that's the information. You get the information. Okay. So what are the examples of transmitter and receivers? So we have a microphone, we have a mouse, we have a speaker, we have a TV, we have a keyboard. Now, are they transmitter or receiver? Remember, transmitter transmits or it propagates the information. Receiver receives the information. So which category does a mic belong to?
Transmitter.
Transmitter, betul. It's a TX because we provide the input. So it takes the input and, puts it wherever it needs to put lah. Right. And what about mouse?
Transmitter. Monitor will be the receiver.
Transmitter, monitor is the receiver. Correct, because we are providing input. The input is our hand movement. Right. So this is also a TX. And I think everyone knows this. What is it?
Speaker.
Speaker. Yeah. What is it? A transmitter or is it a receiver?
It will be the receiver.
Receiver, betul, RX, and we also talked about this, the TV is a receiver. This guy,
Doctor, how about speaker that have, like, you can put SIM card or receive the information from the Bluetooth? Is it like transmitter and receiver?
are you providing input to the speaker?
I think some speaker can do that.
Sekejap.
What if it can be both? So it is both, transmitter and receiver.
Okay, when you mention that the speaker is both transmitter and receiver, how does it transmit the information?
Maybe I think if it from the SIM card, maybe the SIM card is the transmitter, I think.
The SIM card is the transmitter.
And if from
Oh,
the
nak
phone,
connect ke maksudnya?
and if from the phone, maybe the phone lah transmitter, right?
The phone is transmitter, betul.
Uh,
Oh, okay. If the speaker is on the phone, you mean?
hmm,
Kalau speaker je, if it's just the speaker, I don't think so because it's not like you can press anything to change,
ah,
and it's not
or
communicating
unless it's a radio, right?
unless it's a radio, betul, betul radio, betul. Okay,
Betul.
so if it's just a speaker, it's a receiver. Kalau it's your phone, yes, your phone has a speaker as well. Your phone is both transmitter and receiver. Okay. So the keyboard, what about the keyboard? The keyboard is we are providing input or are we receiving input? We are providing, right? We are tapping.
Right.
So
Yeah.
it's going to be TX. Okay. So the one that we talked about just now, which is the phone is both a transmitter and receiver. So this is called transceiver. So it performs to both modes. Okay. So transceiver is the first term. And then I'm going to talk about signal attenuation, which is also known as signal degradation. It occurs in all mediums of transmission. So just now we talked about TX, and then we have our medium, and then we have our receiver. So signal attenuation happens here. Okay, and then the receiver will get a degraded information or something like that. Okay, and then noise comes from many sources. Actually, noise is part of signal attenuation, and we will talk more about this later on. Comes from many sources. Component thermal agitation, sometimes it's too hot, causes the medium to not transmit your information properly. Power lines, atmospheric phenomena like weather, lightning, and other electrical equipments. And then it is experienced the most at the receiver, and this is expressed as SNR, signal to noise ratio. and the unit is in dB. We'll talk more about this. This is just like an intro. Okay. Okay, so there are three types of electronic communication. There is half duplex mode. Half duplex mode means that when one is sending, the other needs to stop. A is sending, B is receiving. B cannot do anything. B cannot do anything. It needs to pause. And then when B is sending, A is receiving, A needs to pause. So for example, like walkie-talkie, when you are using walkie-talkie, only one person can talk, right? I'm saying hello, hello. The other guy is listening, hello, hello. But if you want to talk at the same time, it doesn't work like that. So that is half duplex mode. Only one communication at a time. Okay, when A is sending, B is only receiving. B cannot send at the same time. When B is sending, A is receiving, A cannot send at the same time. So only one can send. Okay, so that's half. So and then we have full duplex mode. This is our phone. We can talk at the same time. Um, Sometimes it's not preferable, but it happens. Talk at the same time, so dengar kacau bilau lah kan. So bidirectional conversation. So B is talking, A can also talk, something like that. And then we have simplex mode, only one direction. For example, our keyboard, our satellite, our remote control drone. I can only send information. That equipment cannot send information back. I can only transmit, because keyboard, I can only transmit, and then the information is transmitted to my laptop from the keyboard. But the laptop cannot control my keyboard. So that is what it means by one direction only. Okay, so if you see your keyboard, suddenly tapping on its own, it's not the laptop, it's a ghost. Okay, so it's not part of the communication. All right, moving on. So types of signal, we have analog and digital. So analog signals vary continuously. For example, how do I say this in a easy way? Okay, our voice is analog. Our voice is analog. If I want to transmit my voice through um, through the phone, right? I need to digitize it. And when it is digitized, it is break apart. For example, this is my voice. This is the wave of my voice. For example, if I want to transmit it to another receiver, to a receiver, I need to digitize it. And what it means by digitization is that I need to make it into different I need to I need to separate them into small values. Okay, I think that we should explain it. I need to separate them into small values. For example, so the resolution.
Sampling quantization process.
Yes, sampling. Oh, you guys have already learned about sampling, is it?
Yeah, in DSP.
Okay, okay. So you know what digitalization means. Okay, so sampling, betul. Sampling is the right word. Okay, so you need to sample it to quantize it, and then you send over bits, right? Okay, so this is how it looks like. Obviously, this is not representative of this. Memang lain lah, this is not it. So this is an example of digital signal, and this is an example of analog. Okay, moving on. So we are going to learn about modulation and demodulation. So modulation means you are you are transmitting information by changing a carrier wave. Okay, you have your message. Your message is your audio. You are going to use this audio to change the wave. When you change it, you transmit it, and when they get this changed wave, they decode it and separate into message and also carrier. They separate it. And then what that person is hearing is your audio, right? Because they have separated it. So modulation is or changing, combining message with carrier signal. And we will talk about what carrier signal is. Okay, combining. So modulation is you have your information, You combine it with the carrier signal. When you combine it, it becomes a complex, transmit it, and then the person receives this complex signal, and their device will separate this complex signal into message signal and also carrier, so that they can actually listen to what this message is. So this is how communication works: modulation, demodulation. Okay. So we have an example of Wi-Fi data transfer here. When you send a message or watch a video, your device encodes or modulates digital bits into radio waves that can travel through air. And then the other device that receives the signal decodes or demodulates it back into usable data. That's something that you can see, right? Because you don't want to see bits, right? Okay. Oh, sorry, not this one. And then we are also going to learn about multiplexing and demultiplexing. Multiplexing just means combination of many signals. So for example, we have a TV station send many channels over the same satellite or cable frequency. So Astro, let's just use Astro. Astro has this package. This package has 70 channels. So to actually let you decide which channel you want to use, Astro has to send all these 70 channels. So this is multiplexing. Astro sends 70 channels. You are receiving 70 channels, but you don't want to see all the 70 channels, right? You only want to see one at a time because your eyes are only one set. So you tell the demultiplexer that I want channel number 5. So from the 70 that has been combined, they are going to decombine or demultiplex so that you can actually select only one channel, which is channel number 5. So that is multiplexing, sending over one channel. Sorry, so send many channels over one route, receiving over that route, separating that complex channel that has been lumped together and separating them into their respective channels again. You are going to select only one or two. Okay, so that's demultiplexing. Okay, so here I have I asked ChatGPT, can you like make this simpler so that my students can understand it? So the analogy was like a highway. I don't know if this is going to help or not, uh, because I didn't learn using analogies. So this is many roads merging into one. So all these cars that was previously from a different road, they merge into one road. So they are all moving together into this one highway. And then when they are going to pick their destination, this is maybe exit Melaka, after Melaka apa Johor, right? So they are going to be demultiplexed into their separate channels. Okay. Oh, sorry, this one is not it. Okay. Let's take a 5-minute break. If you have any questions, you can ask. Otherwise, you may take your 5-minute break. Let's come back at 3:42 and continue. Okay. Any questions?
So far so good. No question for now.
Okay. What about the rest? Okay. No questions. Okay. All right. So take your 5-minute break. I'm going to get some water. Okay, so I'm back. Hopefully, everyone is back as well. Let's continue. We stopped here. What we have talked about so far is the general communication system, whereby we had the transmitter, we have the communication channel, sorry, the medium of communication, and also receiver. And the medium of communication can be disrupted, or the signal can degrade over the medium channel through noise. But we have not talked about in detail what kind of noise and how it degrades the signal, right? We have also talked about different devices that are transmitters. We have talked about different devices that are receivers. We have also talked about transceivers, whereby that device can function as both a transmitter as well as a receiver. We, I introduced to you modulation and demodulation, as well as multiplexing and demultiplexing, but not very technical, just the analogy. Okay, so moving on, let's talk about frequency and wavelength. So frequency is f, denoted as f, the number of cycles of a repetitive wave that occurs in a given time period. The unit is cycles per second. So how many cycles can we get in 1 second? That is the frequency. So the unit is cycles per second, CPS, or hertz. So both of these are the same. So hertz is 1/second, right? So it's the same, cycle per second. And then we have wavelength. This is called lambda. Okay, pronounced lambda. Lambda is equal to c/f. C is the speed of light. Speed of light is 3 times 10 to the power of 8. Okay, wait, I don't like this color. 3 times 10 to the power of 8. A meter per second is the speed of light. So lambda equals to speed of light divided by frequency. And this is the distance occupied by one cycle of a wave. So if we talk about wavelength, it basically means one cycle, distance of one cycle, expressed in meters. So what's the difference between frequency and wavelength? Of course, this is the difference, the equation. So lambda is the distance, this is in meter. This is, okay, this is too much. Let me do this somewhere else. Okay. So unit is also one thing that I emphasize in this class, because I don't really like memorizing. So how you can establish that your equation is correct is by looking at the units. Okay, so lambda is equal to c/f. So lambda is in, so c is 3 times 10 to the power of 8 meter per second, right? And then we have frequency, which is also per second. So when you have per second over per second, what you're left with is meter, which is the unit for lambda, which is distance lah. Okay, so lambda is in meters. C is in meter per second because it's speed. Frequency is 1/s, or hertz. Same thing. Okay, cancel out because they are the same. So I'm left with meter, which is the unit for lambda. Okay. So here we have frequency and wavelength. So A shows me, this is A, by the way. A is one cycle in unit time. One cycle in unit time tells me frequency. Okay, so let's say one cycle is 0.2 second. So how many cycles can you get in 1 second? You can get 5 cycles, right? 5 cycles in 1 second. So the frequency is 5 hertz, something like that. We'll do more exercises later. Don't worry, I'm just throwing it at you guys so that you guys start thinking, okay? Nanti kita buat exercise. And then for B, one wavelength is in unit distance. So here it's pointing, this is one wavelength. Is it really one cycle? This is half of this, and then we have this, and then we have this. So it is one cycle complete. This is combined with this to get one cycle, like that. So one cycle is one wavelength. One wavelength is also like this. This is also one wavelength. So it doesn't matter how it looks like as long as you can establish, okay, this is one cycle. That is one wavelength. Okay. So it's just showing to you that the shape can be like this. The shape can also be from peak to peak. Okay. All right. Moving on. Okay, let's do some example. Frequency and wavelength example. So here I've put this as a guide. You obviously need to remember it for your quiz and test because it's not going to be given. Um, this is easy, right? This is supposed to be easy. You already have this in high school. Okay, so find the wavelengths of 150 megahertz, 8 gigahertz, and 70 kilohertz. So first thing first, you need to write down the equation. So the equation for this is lambda equals to C over F. Okay, it's asking us to find the wavelength lambda of this frequency. This is also frequency. This is also frequency. Okay, A. So lambda is equal to 3 times 10 to the power of 8 meter per second over 150. Now mega, what is mega? It's 10 to the 6 times 10 to the 6, and the unit for hertz is over second. Okay, so cross out, I get meters. So 3 times 10 to the 8 divided by 150 times 10 to the 6. I don't know what that is. Maybe you can calculate that later. So that is how you do it. Then B,
Dua.
dua eh? Dah kira dah? Pakai using the calculator?
Ah, yes.
Okay, thank you. 2. So 2 what? 2 meters.
2 meter.
So 2 meters, that's kind of big, but that is the answer. Okay, thank you. And then B is 3, lambda is equal to 3 times 10 to the 8 meter per second over 8 times 10 to the 9. That's giga. Okay, and then the unit is over second. Oops. Okay, so what's the answer? Don't know as well. Someone can punch the calculator for me, that would be great. And this one, 10 to the 8 meter per second, and 750 times 10 to the kilo is 3. 10 to the 3, 1 over second. Okay, so you'll get something in meters. So that's how you do it. Okay, number 2. So this is 2, this is 3. A signal of wavelength 1.5 meter has a frequency of, this is very easy, 1.5. Okay, first remember equation. Okay, lambda equals to C over F. And then dia cakap wavelength is 1.5 meter, 3 times 10 to the 8 meter per second. This is fixed. This will not ever change. Okay, so it's always 3 times 10 to the 8. And then we have to find out what is the frequency. So here, if I bring over frequency here and this guy over here, the meters cancel out, and what you're left with is 1 over second, which is the unit for frequency. Okay, so I think you can do the calculation yourself. I'm just going over the problem with you, okay? And then number 3, the maximum peaks of an electromagnetic wave are separated. Okay, peaks. Contoh, oh, that's a bad wave. Let me try again. Okay, this is hard. Still bad, but we're going to roll with it. So it's saying that the maximum peaks of an electromagnetic wave are separated by a distance of 0.2 meter. Now remember, peak to peak is also one wavelength. How do we know this? Because, oh, this is so bad. Sekejap. How do I make this? Okay, macam tu. Alright. So we have half of a wave here, and then a quarter of a wave here. So peak to peak is also one wavelength, right? So lambda is 0.2 meter. So C over F. So find out F. C is 3 times 10 to the 8. Okay. Is that okay with everyone? Is there any part that you don't understand that I need to repeat? So no questions yet. Okay. No problem. Ke ada? Kejap saya tengok chat box. Okay, Amri, yes. Or is Amri...
Tertekan atau sorry.
Okay, dah agak dah. Okay, tak apa. Okay, moving on. Whoopsie. So I already put it nicely here because I know my handwriting is bad. So this is how you solve it. Okay. All right, so let's move on to the electromagnetic spectrum. So, okay, so our communication system is, when we talk on the phone and stuff like that, we are actually occupying one band of the electromagnetic spectrum. Okay, where is that band? Okay, let's find out. Sekejap, saya cari sekejap. Okay, so this is optical. Tak ingatlah pula kat mana. Okay, sekejap. Okay, sorry. Let me just go over this part first. Okay, so this is visible light. Visible light, Visible light is within the optical spectrum. Okay, what is visible light? I think you know this. Visible light is the light that you can see, the colors that you can see, black, red, blue, green, red, whatever lah. All the colors, they fall in this spectrum. So they are also part of the electromagnetic spectrum. You see colors here? This is electromagnetic spectrum within the visible light range. Okay, some things you can't see. This is called UV. UV is from the sun, right? You can only see UV under a certain lighting. Remember, if they put sunscreen, and when you just observe it like that, you can't really see the sunscreen. But when you put it under UV light, sunscreen is now black. So that is UV. Under certain circumstances, you can see how it looks, but using our eyes as it is, we can't really see UV. So that is in the UV range. And then infrared range, you already have experience with infrared, believe it or not. Your remote controllers, the red light is infrared. That is infrared communication. Tiba sesama pula. That is infrared communication. So that is occupying the infrared band in the electromagnetic spectrum. Okay, so these are the bands that are very familiar to us, and we are happy with it. And then moving on to this part, we have X-rays, gamma rays, cosmic rays, etc. So these are the dangerous types of waves that need to be used under precaution. Okay, so do not expose yourself to X-rays more often than necessary. Okay, that's why when we go for X-ray, you need to wear like some protective gear so that the X-ray will only shoot at a certain part, something like that. Okay, so if we notice, when going to the right, wavelength decreases, but the frequency and energy increase. Okay, so this is why X-ray is very, very dangerous, because the frequency and also the energy increase. So it's at the maximum lah. And then going to this side, we are increasing the wavelength, but we are decreasing the energy. So these are like safe zone, the safe zone. Okay. So you have extremely low frequency, voice frequency, very low frequency, blah, 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 all of those stuff here. Okay. So if you want to read more on it, there are some applications in these frequencies. Okay, broadcasting, half duplex uses high frequencies, and then microwave is 1 to 30 gigahertz. You have satellite, you have LANs, Wi-Fi. Okay, so this is just for your reading. And then the optical spectrum, infrared, visible region, red to violet, and then you have your UV region, UV lights, etc. Okay, so we are actually interacting with electromagnetic spectrum, whether you like it or not. It is around us, and we are also using it to identify colors and protect ourselves. um, when we identify certain types of waves, we are equipped to protect ourselves, which one is dangerous, which one is not. Okay, so it's very important to be educated on what is dangerous and what is not, and the different types of waves. Okay, so moving on, we talked about the electromagnetic spectrum, briefly told you, infrared is what, UV is what. Now we are going to talk about bandwidth. Now, bandwidth in the electromagnetic spectrum is a certain range. For example, the bandwidth for SHF is 3 gigahertz to 30 gigahertz. So what is the bandwidth? Bandwidth is the difference between the highest frequency to the lowest frequency. SHF bandwidth is 30 minus 3 gigahertz, something like that. So bandwidth is how much are you occupying in the spectrum. Okay, how much you are occupying in the spectrum. So here we have band from 300 hertz to 3000 hertz. What is the bandwidth? So the bandwidth is calculated by F2 minus F1, which is 3000 minus 300. So you will get 2700 hertz of bandwidth for this particular application. We don't know what it is, but it's asking us to find it. So this is the bandwidth. Okay, so automotive radar has been assigned a bandwidth of 5 gigahertz, for example. If the low frequency limit is 76, what is the upper frequency limit? So it's not hard to calculate these things. The math is actually very simple. What's hard about this class is the terminologies that is used to describe certain things. So you need to understand, what does this terminology mean? What does this mean? What does this mean? So that you can relate it back to the math. The math is simple. I can promise you that. But the terms, you have to understand what they are. What is bandwidth? What is skirting? What is, there's a lot of stuff that we're going to learn. What is modulation? What is demarcs? Something like that. Okay? So bandwidth, we already know bandwidth is higher frequency minus lower frequency. So here it's asking us what's the upper frequency, which is the higher lah. So this is going to be our lower frequency, or F number 1. Let me write this nicely. So this is going to be F2 and this is going to be F1. So if bandwidth is 5 gigahertz and the equation is F2 minus F1, F2 we don't know yet what it is, F1 is 76 gigahertz. Okay, so just do the math. F2 is what? 76 plus
81.
81. Okay, so F2 is 81. Laju.
Doctor, is it like the bigger number is always the upper frequency limit, right? F2.
Yeah, betul. Upper is always going to be the bigger one.
Uh,
Upper is always bigger.
ya, dia bagi yang low kan.
Oh no, not necessarily. They're not gonna always give you. Oh, okay. If they ask you for upper, yes, they are going to give you low lah. If they give you the upper, okay, I can change this question. So the automotive radar has been assigned with a bandwidth of 5 gigahertz. Okay, let's change this question. If the upper frequency limit is 76, what is the lower frequency limit?
71.
Betul? Betul? So kenapa terbalik ni? F2 minus F1. Okay, bandwidth is F2. I got my handwriting. Okay, so if the upper is 76, this is 5 minus F1, therefore F1 is going to be 71. Okay. So there's lower frequency limit, upper frequency limit.
F2 minus F1 kan?
Yes.
Not will be other than that
Oh, tak ada.
Okay.
Okay, so that's upper and lower. Is everyone okay?
Okay.
No questions? Okay, all right. Gonna move on. Okay, I already put it here. Okay, just in case. All right, so what have we talked? We talked about electromagnetic spectrum. We talked about bandwidth. Now let's talk about gain. Okay, gain ni um, okay, I'm not trying to scare you, but most students don't understand how to calculate gain. Okay, truthfully. So I hope you can focus on learning what gain is. Right. So gain is amplification. Very simple. Amplification means to amplify. It means where the output is always going to be bigger than the input. Okay, amplify. We put in something, amplify means the output is going to be bigger. So if a signal is applied to a circuit and the output has greater amplitude than signal input, the circuit has gain. Okay, that's just the definition. We'll just remember this. Output greater than input, okay, gain. Okay, so how do you calculate gain? So gain is calculated by dividing V out over V in. It can also work by P out over P in. It can also work as I in, oh my god, I out over I in. Okay, you can calculate gain like that. It's always output divided by input. What is the gain? So when two or more stages of amplification are cascaded means that you put the amplifier next to each other. So they are subsequently um, arranged. So here you have amplifier number 1, amplifier number 2, amplifier number 3. Now this is for A1, this is going to be the V out. This V, yes. And this is going to be the V in. But for A2, the V out is now the V in. Then you have a different V out. So this is V out number 2. This is going to be V in number 2. So V out number 1 is actually V in number 2. And then V out number 2 is actually V in number 3. And then this is the final V out. So the final V out divided by divided by the V in divided by 1 millivolt will give you A total. Okay, looks simple enough, right? 60 millivolt divided by 1 millivolt, the amplification is 60. Now, you observe here, there's no unit. Why? Because volt has been divided by volt. No unit, it's unitless. Amplification is unitless. Okay, another thing that we need to remember is when output is greater than input, you will always have a value that is greater than 1. Let me write it here. Always greater than 1. So because why? Because the output is always bigger than input. So whenever you divide V out minus V in, so divide by V in, you're going to get something that is greater than 1. If V in is equal to V out, what happens? V out is just divided by V out, you'll get 1. There's no amplification, zero amplification or nothing. So that's not amplification. Amplification, the output must always be greater than input. Therefore, the gain will always be greater than 1. Okay. Is everyone okay with that? All right. So that is one part. Now, if I have the different gains, I know the different gains of this amplifier. A1 has a gain of 5. A2 has a gain of 3. A3 has a gain of 4. How do I combine this gain so that I don't have to cut, I don't have, let's say we don't know what 60, we don't know this value, we don't know, we only have this value, but I have this A1, A2, A3. I can calculate what is V out based on the total gain. Now, if I have 5, 3, and 4, I need to multiply these 3 to get the total gain. So it's 5 times 3 times 4 is 60. Okay. Is everyone okay? I think that was a lot of information. But you'll survive. You are smart. Okay, let me rephrase this. Okay. Let's say I don't know this, right? Let's go over that problem. And I have V in equals to 1 millivolt. I know this information. These are the information that I have. So I know A1, A2, and A3. So what I need to do is I need to find out what is going to be V out. So how do I find out what is V out? So I need to use the gain equation. V out over V in is equal to A. How do I get V out and V in when they are so far apart? Which means that A is not just A, it's A total. So you need to figure out what is the total amplification of this system. It's a system. So to find out A total, I need to multiply A1, A2, and A3. So I will get this as 60. And if I know what V in is, which is 1 millivolt, I can find out what is V out. Okay, so that was just rephrasing what I talked about earlier. Right, moving on. Okay, more examples. I hope you're ready. Okay, so what is the voltage gain? Voltage gain of an amplifier that produces an output of, this is the output, so this is going to be V out for a 15 microvolt input. So this is going to be our V in. Okay, so it's asking us what is the voltage gain? What is A? Easy, right? 650 millivolt divided by 50 microvolt. This is equal to A. Now I can't do this as it is, so I have to change it. 750 times 10 to the minus 3 volt, and then 15 times 10 to the minus 6 volt. Now I can cross them out.
50,000.
50,000. What's the unit?
No unit eh.
No unit. Betul. That was a trick question. Okay, good. So A is 50,000. So next one, actually I don't know if that's the right answer, but hopefully you use your calculator correctly lah. Okay. All right. Next one, the power output of an amplifier. Okay, output, so this is going to be our P out. This is a power problem. The power gain is 80, so this is A. What is the input power? P in. Okay, so A equals to P out over P in. And then we know what A is. So A is what, 80. P out is 6 watt. And then we need to find out what is P in. So P in is equal to, I don't know, okay, 6 watt divided by 80. Betul ke ni? Salah je ni. Power gain is 80. Output is 6 watt. P in. Oh, okay. What's the P in?
0.075
0.075. What's the unit?
watt.
Watt. Okay. Okay, is everyone okay so far? Am I going too fast?
Tak laju pun kata okey je.
Okay, so thumbs up. All right, thank you for the feedback. If you want me to repeat any part, please let me know. Okay, let's move on. Three cascaded amplifiers. Now we have a amplifier problem yang more than one amplifier have power gains of 5, 2, and 17. So this is the symbol for amplifier. Okay, 5, 2, and 17, which means that we have a total amplifier. The input power is 40 milliwatt. What is the output power? What is the output power? Sorry, not V. So it's P out. Okay, so P out over P in is equal to A total. So A total is 5 to 17. And then we can equal this to P out over 40 milliwatt. Okay, pretty simple. As I said, the math is simple, but understanding the problem and what is asking is the trouble. Okay, right, moving on. A two-stage amplifier has an input, okay, it's two-stage, input 25 microwatt and output of 1.5 milliwatt. Okay, let me rewrite this so that it looks like milli. Okay, one stage has a gain of 3. So this is A1, A2 is unknown. Okay, so 1.5. Okay, sorry, I need to start with equation. P out over P in. Okay, A total macam biasa. And then we have A1 and A2. A1, A2. Okay, so that is 3 and A2 is unknown equals to P out is 1.5 milliwatt divided by input 25 microwatt. Again, you can't just use it as it is. You need to use milli is 10 times 10 to the power of minus 3. Micro is 10 to the minus 6. You need to know these things. And then you can divide and then find out what A2 is. Again, it's very simple if you understand the question. Okay. Okay, so I wrote it here. I'm going to share it later. But I think it's better if you write it yourself. It's going to stick better. Okay. All right. So we talked about gain. So gain, what can we conclude about gain? Gain, output power or output voltage or output current must always be greater than the input. If they are equal, the input and the output is equal, there's no gain. It's basically just, it's just a wire. There's no gain involved. Now, attenuation is the opposite of gain. Now here, attenuation is output is less than input. The signal is degraded because of, can be noise, it can be resistance, it can be, well, noise can also contribute to resistance, and then thermal can also contribute to resistance. So there's a lot of factors for attenuation, but we need to understand what attenuation does. Sorry, how to calculate attenuation. Okay, attenuation is simply the ratio of output to input. Yes, we know this, except that output must be less than input. Now, circuits that introduce attenuation have a gain of less than 1. Just now, I told you 1 is not gain. Greater than 1 is gain. Now, less than 1 is attenuation. Okay, so these are the general rule. So when several circuits with attenuation are cascaded, the total attenuation is again the product of individual attenuation. So same formula as gain, you multiply them together. But now when you multiply, it's going to be values like 0.2, 0.3, 0.5 because they are gain. They are attenuation, which is less than 1. If its gain is going to be 2 times 30 times 5, it's always value greater than 1. Okay, so you will get something like this. So if you put in 3 volt, you're going to get something that is less than 3 volt. In this case, you got 0.0324 volt. Okay, so I think this is okay because if you understand gain, you will understand attenuation. So,
Data
yep,
basically sama je kan macam gain, cuma nombor dia tu less than 1
yes, correct?
kan.
Yes, good. So you multiply these different attenuators. Just now we said amplifiers, amplify. So attenuation, attenuators. So 0.2 times 0.9 times 0.06, you will get a total attenuation of 0.0108. And then you just plug in V in, oh sorry, V out dulu.
Oh, simbol dia still sama Dr. A.
Yes, yes, the symbol is still A.
Oh, so if want to differentiate is to look at the numbers lah.
Yes,
Less than
correct.
1 attenuation, more than 1 is gain.
Yes, betul? The symbol is the same. It's still A. Okay, that was a good question because I forgot to mention that. Right. So let's take a look at this circuit. Okay, so this is drama from year 2, right? Circuit analysis, semester 1. Betul. So it's back to haunt you. So this is a voltage divider. Very simple circuit voltage divider. We have V in. This is V out. So to find out what is V out, you need to find out the voltage of here divided by the voltage of here. Voltage, sorry, current. Okay, so to find the current, it's going to be a ratio of R2 over R1 plus R2. So that's at least how I vision this calculation lah. Okay, how do I make this? Um, kejap, kejap. Okay, let me try to rephrase that. So I want to find out the V out here. Okay, this is the aim. Okay, the aim is to find out V out at this point. So how do I find out V out at this point if I know R1, R2 and V in? I don't know what V out is. Okay, so V out is going to be the voltage across here. So the voltage across here is R2, right? So it is going to be the voltage across here. The total voltage is going to be the voltage across these. Okay, across this. Total input. The input that we are supplying is going to be the total. Okay, total. Okay, total is going to be R1 plus R2. I only want to find out this part. So it's going to be R2 over R1 plus R2. Remember, this is total voltage. This is the voltage I want, which is here. So this is the ratio. Now I multiply this with V in, which is the total voltage, to actually find out what V out is. Okay, so that is how you find out the attenuation from the circuit lah. So R2 is what? 100. So this is already all over the place. Okay, R2 is 100. 200 plus 100 times with V in. V in, don't know what the value is. So if a signal of 10 volt is applied, V in is 10 volt. So this is going to be 100 over 300 times 10 volt. You will find out what is V out. Okay, so it's just, no, that's not the answer. It's going to be 3.33. Okay, so this is a ratio problem from a circuit that causes attenuation. Is that okay with everyone? Baru satu circuit. Okay, does anyone want me to repeat? Okay, kalau if you want me to repeat, please thumbs up. No, no repeat.
Doktor,
Yeah.
attenuation A kan, tapi yang tadi tu bukan nak cari attenuation kan, tadi nak cari V out kan.
Okay, that's a good question. Let me show you why it's attenuation. Okay, so I remember V out over V in. What's the condition for attenuation? V out
out
is
over V
smaller
in.
than V in, right?
Oh, so guna V out tadi over V in
So
balik lah.
this guy is your A, right? Okay, let me rearrange this. V out, I put V in over here. So it's going to be V in. Does this look like A already? Remember, A is equal to V out over V in.
Yeah.
So this is A. The voltage attenuator is A. Sorry, voltage divider is actually attenuator. It doesn't look like it, but that's how you reduce voltage. So it's called attenuator as well. So it does the attenuation for you. Okay, so now we know how the circuit looks like in a voltage divider. What if someone sold this to you in a box You put in V in of 10 volt, you get out 3.33. Oh, and then you tell me, oh, this is an attenuator, doctor, it works. But it's actually a voltage divider. That's what it does. You just see it as a box. Previously, what you see was this, V out. You get 3.33 from 10 volt. You say it's a attenuator. When in reality, this is what's going on. And our job as engineer is figuring out what's inside. Okay?
So attenuator is somehow a voltage divider.
One application is voltage divider. There are many other ways lah.
Oh, okay.
Okay? Is that clear for everyone? Any other questions related to this? Okay. All right. Yeah. Okay, maybe let's take a 5 minute break again. 4:28. Let's come back. Okay, let me pause myself. Okay, so let's continue. So now we talked about, we've learned about gain. We also learned about attenuation. Now what happens if we combine amplifiers and attenuators within one system? So same case, you still have to multiply each value of attenuator and each value of amplifier to get the total amplification of the system, or maybe it's the total attenuation, we don't know. Sometimes it can be when you multiply all of these together, sometimes you get gain, sometimes you get attenuation. Okay, so in this case it's gain because it's more than one. So in this case we have attenuator 0.1, and then we have an amplifier 10, and then we have an attenuator with value 0.3, and then we have an amplifier of value 15. So you multiply these together to get the total amplification of the system, and you get 4.5 as your gain. And then if you have V out, you can find out what is V in, or if you have V in, you can find out what is V out, and vice versa. Okay, so this is straightforward. If you understand what gain is and what attenuation is, I think this is no problem for you. Okay, all right. So we have a problem here, attenuation example. A voltage divider shown below has values of R1 of 10 kilo ohm. Okay, so this is 10 kilo ohm, and then R2 is 470 ohm. This is 470 ohm. What is the attenuation? So remember, we have V out over V in equals to A, or our attenuation or our amplification works both ways. So in this case, this is attenuation. So V out is going to be, sorry, attenuation for this is going to be R2, okay, because we want this, we want this part over R1 plus R2. And this is going to be V out over V in. Okay, so what is the attenuation? R2 is 470 ohm, and this is 10,470 ohm. Okay,
0.045.
0.045. Thank you. So there are no units because it's attenuation, same like gain. Okay, no units. Thank you. So what is attenuation? The answer is 0.045. Number two, what amplifier gain is needed to offset the loss to get an overall gain of 1? Yeah, I wouldn't say gain lah. To get, okay lah, you need to say gain. To get a value of 1, basically. So here we have attenuation. Let's call this as A1. Okay, so this is A1. So it's asking us what, okay, we have this, right? We have V in, and then we have our A1 here, and then we have V out. Now it's asking us what amplifier gain is needed to offset this loss. So to get our, to offset this, we need to put an amplifier, and then we will call this as A2. Okay, we will put these together so that it gives us V out over V in equals to 1. And then this is going to be A1 and A2. Okay, offset means like to counterbalance or to cross. I think that's the best I can explain lah. Offset is to like counter so that it becomes 1 or no gain. So V out over V in equals to 1. This is going to be total attenuation or total amplification. So you just multiply these two to get what A2 is. So let's do this properly. Okay, this is bugging me. Let me put this out. We have this value 0.045. Okay, so again, the question is asking, what do I need, what amplifier, what value amplifier do I need to offset so that the total system gain is 1? Okay, total system gain 1. I know I said 1 is not a gain, but here The question specifically asks us for one, so let's just roll with it. So V out over V in, not that it matters here. And then we have our A1 and A2. Okay, so this is what we have. We know what A1 is. A1 is 0.045. We know what the total amplifier is, amplification is 1. Okay, so I can solve for this. So 0.045, and then we have A2. So A2 is
22.22.
22.22. Thank you. So this is A2. So 22.22 is the value of the amplifier needed to counter or offset the attenuation by A1 so that the total system is 1. Meaning to say V in is equal to V out. You're gonna get the same thing. Okay, right. All right. We have another 30 minutes. Sorry. We have another 25 minutes. So, jap kita tengok. We have decibel, dBm. Okay, sampai good. Right. So now this is going to be a new, not really new topic lah, new subtopic. We talked about gain, we talked about attenuation, we talked about the combination, we talked about voltage divider, we talked about electromagnetic spectrum. There's a lot of stuff that we talked about. Now is a new one. It's called decibel, dB. dB. The B is capitalized. D is small, B is big. The gain or loss of a circuit is usually expressed in decibels. Just now, we were doing it in linear. There were no units, right? It was unitless because it was voltage divided by voltage, no unit. Power divided by watt, no units. But now we have a unit called decibel. When gain and attenuation are both converted to decibels, the overall gain and attenuation of an electronic circuit can be computed by simply adding. Just now we had to multiply. When we wanted to know the overall gain or the overall attenuation, we had to multiply. But when we convert each amplifier or each attenuator value to decibel, we can add them. So usually it's easier. Okay, so let's find out how to convert this to decibel. So this is in linear and this is in dB. So in linear, the total amplification or a total attenuation is computed by multiplying the different attenuators or amplifiers. So A1 times A2 times A3. But in dB system, when you convert it, when the value is converted to decibels, you just add them together. See, this is plus. Why am I circling something else? So this is just plus. Senang lah, senang. So, it's easier when you are designing a communication circuit. It's easier. I can attest to this. Okay, so converting to dB, how do we do it? So you have V out over V in, which is basically A, I out over I in, which is basically A, P out over P in, which is basically A. So for for voltage, okay, this is for voltage. To convert amplification for a voltage system, okay, semua system, all systems has power, current and voltage, but sometimes they specify the specification in voltage, right? So assuming we are working with voltage, so you are going to convert amplification in voltage to decibel by multiplying 20 times log of A. Okay, remember this is voltage. For current system, specification given in current, amplification of current, it's also the same thing, 20 log of A. But for power, it is slightly different. It is 10 log of A. Okay, so let's find out how to use this equation properly. Let's go. Okay, so decibels example, the first one, an amplifier has an input of 3 millivolt. Let me write this up here, V in, and then an output of 5 volts. So this is V out. What is the gain in decibels? So right off the bat, I can calculate this in linear, right? V out over V in will give me an A in linear form of 5 divided by 0.003. So I don't know what that is. Something. Okay. This is in linear. The gain in decibel. Now, remember for voltage, the equation is 20 log of A. 20, so right,
Log 10 kan betul?
log n, log n,
Log log tu 10 kan?
log base 10 ke?
Base 10 kan?
Yes, base 10. Betul?
Yang 5 over 3 tu 1666.67.
166.67. Betul?
1666.
1666. Okay. 1666.67.
67.
Okay. Thank you. Okay, so this is A. Thank you. To Shafiq, eh?
Yes.
Okay, thank you, Shafiq. Okay, what is the gain in decibel? So if we go back to this equation, for voltage, we need to use the equation with the 20 inside. Okay, dB equals to 20 log of A. So dB equals to 20 log base 10 of 1666.67, or you can just write 5 over 0.03. So you will get something in dB.
64.
Saya boleh Syafiq ada. Saya tak bawa calculator. Okay,
64.44.
64.44. Okay, thank you.
dB kan?
dB, betul. This is dB. When you use the log and then you multiply by 20, you get something in dB. Okay. So what is the gain in decibels? The gain is 64.44 dB. So if the A is attenuation, for example, A in linear form is 0.3, in dB, A in dB will become minus. This one is positive. Become minus. A in linear is greater than 1. A in attenuation in linear is less than 1. But for dB, gain is positive. In attenuation, dB is negative. Okay, so let's find out in another example. Is this? Yes, this is attenuation. So let's do this one. Okay. So I need maybe I need Shafiq again to help me with the calculation. A filter has a power input. Okay, so P out, sorry, P in is 50 times 10 to the minus 3 or milliwatt. And then P out is 2 times 10 minus 3, or it's the same. Okay, so A in linear is 2 milliwatt over 50 milliwatt. What?
0.04 ampere.
0.04. And then we convert this to, is this in dB already? Tak kan?
Sorry. 0.04. No, yeah. 0.04.
Okay. Then we convert this attenuation in linear scale to dB scale. So this would be, this is power. Okay, power, so power equation is A dB 10 log base 10 of P out over P in, or we can just put A over here. So that is going to be 10 log of 0.04. The answer is
Negative 13.98.
negative 13.98 dB. Okay, so here you can see for gain, this is gain, you get dB that is positive. Oh, you get a dB that is positive. For attenuation, which is less than 1, you get dB that is negative. Okay, so now it's asking what is the net gain of the amplifier and filter in question 1 and 2 in linear scale and in decibels. So I'm going to let you guys do this. Try. Okay. Okie dokie. So when a circuit has a gain, the decibel value is positive. When a circuit has attenuation, the gain is less than 1, therefore decibel value is negative. let's say we know what the decibel value is, but we don't know what A is. We don't know what A is. So how do we convert from dB back to linear scale? Okay, so here I have this equation. This is the regular equation that we have used just now. A dB equals to 10 log base 10 P out over P in, or we can just say this is A. Okay, so to get rid of log, okay, this is a bit of math. To get rid of log, you need to you need to use exponential. Okay, so how do you do that? So first, I'm going to divide A with 10. Okay, I'm bringing this over here. Nothing fancy. It's just divided by 10. Okay, so what I'm left with is log base 10 with A. Sorry, this is dB. This is, okay, let me not write this as A because it's going to be confusing. So let me write this as P out over P in. Okay, so this is what I have. One side has nothing, one side is ADB divided by 10, one side is log 10 P out over P in. How do I get rid of log? Is I need to use the exponential 10 to the power of this thing, because I'm using 10 because this is log base 10. Okay, so 10 to the power of log base 10 P out over P in. Okay, bear with me. 10 to the power of log 10, sorry, 10 to the power of log base 10 P out over P in. Okay, and if I exponential one side, I need to do it on the other side as well. So this is going to be 10 ADB over 10. Forgive my handwriting. Okay, so this is what we have. This is the situation. So when we have 10 to the power of log base 10, this guy cancels out. Alhamdulillah. Okay, so what you're left with is P out over P in 10 to the power of ADB over 10. Okay, let's say the dB is 4, kan? Value is 4, so it's a gain. So if it's a gain, I'm expecting P out P out that is greater than P in, or A is greater than 1, right? So let's say this is 4. So I'm going to get 10 to the power of 0.4.
2.5.
So this is going to be 2.5, which is equal to P out over P in. So this is in linear scale. Okay, was that okay? This is a bit of math. I know you already learned this, but I know you already forgot it. So that's why I'm going through the motion. So okay or not? Boleh buat?
Okay lah, but a bit confusing tapi still okay.
Anyone wants me to repeat? No? Malu lagi. Okay, tak apa. Right, so moving on. So this is just a table that shows you dB in gain or attenuation. Sekejap. dB, this is ratio. Ratio of 1 in power is 0 dB. Is this what it is? Okay. Ratio of 2 is, okay, so this is what it is. Okay, power in dB, and this is voltage in dB as well. So ratio here means A, ratio of output over input. Ratio of output over input. Okay, so let's say the ratio is 1. No gain, no attenuation. Therefore, the dB is 0. In power, the voltage in dB is also 0 for voltage. Why do we have a separate column for power and voltage? Because the equation is different. Remember, AdB 20 log A and AdB 10 log A. This is for power and this is for voltage or I. Basically I lah. Okay. So this is why we have the different column, therefore different values. Okay, so if the ratio is 0.5, this on here is going to be attenuation. And here from here is going to be gain. So attenuation will give you a negative dB, gain will give you a positive dB. So this table just gives you an idea of how ratio is converted to power and voltage so that you see the okay, the main point here, I think lah, the main point of this table is when gain is multiplied by 2, the increase in dB is 3 for power. When the division, when the gain, sorry, when the attenuation is divided by 2, which gives you 0.5, it's minus 3. When the gain is 10 times, the dB is also 10. When the attenuation is 10 times 0.1, the dB is also minus 10. So there is like pattern lah that you can memorize. When you become an engineer for radio frequency and stuff like that, sometimes you need to memorize these values because okay, what's this times 2 is 3 dB increase in signal. So something like that. Okay, so this is just an exposure. Don't have to memorize. All right, decibels, try it yourself. I have provided the answer. You can try it later. Okay, this one, I think I'm going to go through this one with you. A power amplifier has an input. Okay, first keyword here is power amplifier. Input of 90 volt across 10 kilo ohm. Okay, power tapi but input of 90 millivolt across 10 kilo ohm. So power with voltage and resistance, the equation is this. Oh no, I have 10 more minutes. Okay, I have another meeting. So power, if I have voltage and also resistance, the equation is V squared over R. Okay, so power V squared over R. Bear with me, just 10 more minutes. So this is going to be 90 times 10 to the minus 3 squared divided by 10 times 10 to the to the power of 3. Okay, so this is going to be your power. This is input power. Okay, P out pula is 7.8 across an 8 ohm speaker. This is R. This is also R. Okay, so again the same equation, V squared over R, 7.8 squared over 8 ohm resistance. So this is going to be your P out. Then after you have found this equation, they want the power gain in decibel. So A in dB, power is 10 log base 10 of P out over P in. So you just plug in these values and you can find out what AdB is. The answer is given. You can try it yourself later. Okay? Was that okay? So what this question is tricking you is they ask you for a power amplifier, but they give you values in voltage and resistor. So this is something that you need to decode from the question. Okay. So I think I'm gonna stop here. Can we like have like a summary before we end class? And if anyone wants to ask questions, you can also ask. Okay, let me summarize what we have talked about today. So I've talked about myself, okay, and this class schedule. We also talked about the textbook for the class. You can download this. I'm not going to give you the link because it's illegal. You can also go to online library for UPM. I don't know if you know how to access that. Let me show you. Okay, you can see my screen, right? Easy proxy UPM. Okay, easy proxy. If you are outside, easy proxy lah. Just go through easy proxy. And then this is our library, Sultan Abdul Samad Library. If you don't know, ketuk kepala lah. Okay, so this is our library. And then click on easy access over here. Okay, so these are the online databases that UPM subscribes to, which means that you have access to it. It's free as long as you are a student or a staff. I'm going to click on that. And then let's say you know that the textbook lah. For example, you have a textbook in mind. You know that the textbook is in Elsevier database or Scopus database. So you go to Scopus and you find out where it is lah. But you need to know where the textbook is from first before you can actually identify which part you need to go to. Okay, so this is one database. Figure it out, one database. Nak buka ni ke, nak buka ni ke, I don't know. Okay, you can also use these resources for other classes as well. This is one website. Another is illegal. I'm not going to share it with you. I think you know, as a student, I think you know all these illegal websites. Download the textbook from any website that you know. Okay. I'm not going to give it to you because I don't have the authority to do it and I will be sued. Okay. So please find this book. Go through it. Okay. And then we talked about the course outcome for the class. This is what is expected out of you. We also talked about the mark breakdown. So quiz will be on week 4, test will be on week 8. Okay. In column is the lecture that I expect you to study for the test, and this is for the quiz. Okay. This is the general model of electronic communication system. We have information that we want to transmit to the transmitter through the communication channel for the receiver to receive and decode the information. So over the communication channel, we have noise in different forms that we have not covered yet. We have not learned about the different noises yet, but this is the general model and you need to know what is the general model. Okay, so we talked about this: transmitter, receiver, transceiver. Okay, and different types of electronic communication: half duplex, which is like a walkie-talkie; simplex, which is like a keyboard; full duplex, like your phone. Okay, and then we talked about analog and digital. You have learned about sampling, so that's great. And then we briefly talked about modulation and demodulation. Modulation is combining or changing a carrier signal using your message, transporting that signal that has been changed, and then demodulation is unscrambling that complex message to become message and carrier. Okay, so it's almost like multiplexing, except multiplexing is a lot cleaner. Multiplexing is like you stack things together and then you unstack it. But for modulation and demodulation, it's like it's like tangled together, so you can't really see it unless you demodulate it. Okay, so multiplex is much simpler than modulation. Okay, and then we talked about frequency and wavelength. The equation is lambda equals to c over f. You need to know how to use it. And then this is one cycle, which is frequency. Sorry, one cycle is one wavelength. Okay, a little bit more. Then we talked about the electromagnetic spectrum. Infrared is like your remote controller. Visible light is what we see. And then you have UV and X-ray. So the X-ray is the highest frequency and the most dangerous one. The highest frequency, highest energy, lowest wavelength. Okay. Bandwidth, upper and lower frequency. And then we talked about gain, talked about attenuation. We talked about combination of this, and then decibel. Okay, so I'm going to stop here. Next week, we're going to talk about gain and attenuation again, recap, and then I'm going to introduce you to some new things. Okay, so that is it. Any questions?
No, doctor.
What about the rest? Everyone okay? Selarat dah?
Okay, okay.
Okay, okay. All right, so I'll see you next week then. Take care, everyone. Have a good weekend. Bye-bye.
Thank you, doctor.
Thank you,
Bye.
Thank you,
Doctor.
Doctor.
Thank you.
Thank you,
Thank
Doctor.
you.
Welcome. Bye-bye.